All right, welcome to the second set of notes for this unit, actually the second and last set of notes. There are only two for this unit. It's a very short unit. I'm going to, again, do just the highlights, and again, you can pause as you see fit. You can speed the video up or slow it down as you see fit. And here we go. Science only deals with the natural world, really for one of two reasons. There's really only the natural world. I guess the alternative would be the supernatural world. There is no credible evidence for anything supernatural. We've not been able to detect anything that would indicate anything other than a natural world existing. So by default, science therefore has to deal with the natural world. That being said, you are obviously more than welcome to believe in supernatural things. I'm just simply telling you that in terms of science and scientific investigation, which I'm going to argue is kind of not only the only, but it's the best way to understand things. There's just simply no evidence for anything other than the natural world. So we deal with the natural world in science. We propose explanations, we test explanations. Conclusions and statements and conjectures need to all be supported by evidence. And that is one of the hallmarks of science, is that you cannot simply say something and have it be true. It needs to be supported by observations or by data or both, or it needs to be supported by evidence and data. And again, we talked about peer review very quickly last time. Scientists do peer review each other. You can't just kind of slide things in as truth without actually having gone through that rigorous process. All right, so we've gone over hypotheses last time. In science, ideas must be tested. If you have an idea in science that by definition cannot be tested, it cannot be subject to investigation, it is not a good hypothesis, and it's not good science, actually. And this is why a lot of people will say, well, if we just talk about God, and I'm not talking about religion, but any God in general, if you say, well, God exists, that's not a scientific hypothesis, because usually God is defined as being something that we can't interact with. So right from out of the gate, there's kind of like almost like a demarcation there. But again, if you cannot test the idea, then it's not good science. Things have to be refutable. You have to be able to disprove something for it to be good science. All right, observations and inferences. Again, they're pretty self-explanatory. I'm just going to give you a second to just look at this slide. You collect observations either with qualitative, which means you're describing them, right? They have qualities, or using using numbers, quantitative variables. Like in the pulse lab, you measure the number of beats per minute, right? And then typically you'll make some kind of inference, where you kind of extrapolate beyond that immediate experiment, and you try to make conclusions about the world around you. You make inferences about the world around you. All right, here's the heavy hitting stuff. So I'll slow down a little bit to kind of hit some of the main points here. Theories have a bad reputation among people who don't really understand what they are. A theory in everyday life is just kind of like a willy-nilly idea you have. I might have a theory about why my dog likes to lick the floor or something, but in science, a theory has a much, much, much more specific, hi, good girl. Yeah, she's over here, sorry. Here's her dog toy. There we go. She's playing tug with me. In science, they have much narrower definition, but a broader focus, actually. So a scientific theory is a well-tested, and I cannot emphasize this enough, it is a well-tested explanation. It is a well-tested explanation that encompasses pretty much everything. It can explain observations, it can explain facts, and yes, it can even explain laws. So right out of the gate, scientific theories are actually kind of like the crowning achievement of scientific ideas because they are explanations of pretty much everything else, right? Another way to think of a theory, or scientific theories are like the best thing. It's like the crowning achievement, sorry. Another way to think of a theory is like the sum of all of these hypotheses. You know, hypotheses are kind of like baby theories. Like it's a general idea that might or might not be supported by evidence, so you do an experiment on it. A theory is like a really robust, well-tested, well-supported hypothesis over and over and over and over and over and over again. So theories are excellent in science. They're not some squishy thing we're not sure about. It's actually an awesome thing, and I would say they're the best quote-unquote thing to be in science. All of these are theories, right? You've got cell theory, the theory that explains your makeup, right? They're explanations. So what are living things made of? Right? Cells come from pre-existing. We'll do the cell theory later, but you are made up of cells. Cells come from pre-existing cells, etc. The Big Bang Theory it's actually a jokey name. I guess they gave it this name because they were trying to make fun of it, but it actually turns out that there was a rapid expansion of space and time at the start of the universe. So that's the Big Bang Theory. Evolutionary theory explains how organisms change over time. Theory of relativity is from Einstein. Germ theory is that when you get sick, it's because of a bacteria or a virus or a parasite. Maybe it's a hookworm or something. A protist, it's not because you woke up on the wrong side of the bed one day. Atomic theory, everything that is matter is actually made up of atoms, right? Plate tectonics, endosymbiosis we'll talk about later too. But what you're going to notice is that simply because these things are theories doesn't mean we're not sure about them, right? You're made of cells, right? It's cell fact. Things are made of atoms. Matter is made of atoms. It's atomic fact. So why isn't it called cell fact? Why isn't it called atomic fact? Why isn't it called the fact of evolution? Why isn't it called heliocentric fact, right? The heliocentric theory is the idea that we revolve around the sun. That's a fact, but why is it called a theory? Well, go back to what a theory is. It's a well-tested explanation. As long as you are explaining something, whether it's what you're made of, what matter is made of, how organisms change over time, how you get sick, how the universe originated, how the world revolves around the sun, because you are explaining all of those things, they are theories, and they are all well supported. And what you might notice at this point is that, yes, things can be facts and theories simultaneously. And that's the critical thing here. Theories are essentially big explanations that are also facts. Can theories change? Yeah, of course they can. You want your explanations to change as you collect more and more data for them, right? You wouldn't want to keep an explanation simply because you're emotionally attached to it. That's not what science is about, right? If the data doesn't support your explanation, you change your explanation. At the same time, though, and this is the key thing, as you gather more and more evidence that comes to the same conclusion, explanations are more and more durable, which means they are less and less likely to change, right? So if I have a brand new explanation for something, maybe it's only a couple months or a year old, it's really subject to change. But if I have an explanation, say evolutionary theory, that is over 150 years old, that's been tested probably more than any other theory in biology, I can be really confident that that theory is accurate. So two things happen simultaneously. Yes, theories can change. but they are less and less likely to change over time as more and more data comes in. So they can change, but at the same time, they are durable. So let me give you a quick example of how a theory changes. The theory of spontaneous generation is about 200 plus years old. It's the idea that non-living substances can very quickly give rise to living things. We know that the first cells evolved by what's called chemical evolution. So yes, living things can come from non-living things. It happened at least once. But spontaneous generation is about the pace of it. It's about this very quickly. And if you look down here, you're going to see where I'm not joking when I say quickly. This is like 3 weeks down here. Can very quickly give rise to living things. And that's not supported by any evidence because the very first experiments we did were actually not very good experiments. They were pretty bad experiments. And that's also when science was newest, when the scientific theory that you study today was actually being first developed. But this is the idea that you can have things like wheat and some time and you get mice. And obviously this doesn't make any sense. So once we got past our initial round of pretty bad, sorry, the word's escaping me, pretty bad experiments, Reddy essentially came along and did a much better one, and then we've been able to copy it since then. But in this scenario, the control is this flask right here, right? This is the default, just kind of an not messed with open air jar with some meat in it, and what happens? Well, you get flies inside of it, right? That's the default condition, that's the control. These two, the flask sealed and the flask covered with gauze, are the experimental conditions, right? So there are 3 levels to this independent variable, 1, 2, 3. And in both the experimental levels, the cork and the gauze, this very tight gauze that doesn't even let maggots in or eggs in, prevented life from kind of spontaneously popping up in this jar. So this is one of the first experiments that disproved spontaneous generation. Louis Pasteur did a very similar one. He boiled some broth, some agar broth, which is just bacteria food. And this kind of neck attached to this flask actually traps microorganisms. And with this, I'm not going to go over the details of this too much. The point is just that you don't have microorganisms just kind of spontaneously growing in this broth. They have to be exposed to open air so that organisms can come into it. All right, so this theory was discarded, and it was placed with the theory of biogenesis, right? Life comes from life, cells come from pre-existing cells. Again, the exception is way back in Earth's early history, about 3.5 to 3.8 billion years ago. Our first cells on this planet actually did come from non-living things. But the key here is that's in the billions of years. And again, spontaneous generation was just talking about this kind of 3-week turnaround or like 24-hour turnaround, right? That's the kind of quick rise we're talking about. All right, last little bit here, a law. A lot of people think that laws are better than theories. I'm going to try to argue that they are not. I'm going to argue that they are actually a little inferior to a theory. A law is simply a statement of description. It's describing the relationship between multiple variables. It is assumed to be true everywhere in the universe. Everywhere in the universe. And because we're describing, we're not explaining anything, we're just describing with a scientific law, they are almost always mathematical formulas, right? Google any scientific law you want, chances are you're going to find it's a mathematical formula. And this is why I think theories are actually better. Why does that equation work? How did you get that equation? Why do the variables interact with each other the way they do? Why is it x squared and not simply x in your equation, right? If I asked you to plug and chug into a formula, you could do that pretty well. But if I asked you to derive a formula all on your own, That's a lot harder. But in order to derive the formula at all, you need to understand the relationship between the variables, which means you need a theory. And that's why I'm trying to argue to the point, and I hope you guys will agree with me, that theories are actually even more impressive than laws are, because theories explain, whereas laws only describe. All right, so I'll let you review this on your own. A key misconception down here at the bottom is that theories can somehow become laws, or that laws can somehow become theories, and they don't. They do different things, right? The function of a theory is to explain. The function of a law is to describe. They don't become each other, right? They will always be separate, albeit related. Right, so if you can answer this critical thinking question, you guys can read this on your own. You understand the content. You understand that theories and laws are different, but they're related, and that a theory is not a bad thing. And actually, if you watch the video that's also posted along with this, I think they do a pretty good job of explaining that as well. So I will see you guys next time. Have a great afternoon.